Good morning to all. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kyarpuram, Bangalore. Today I am going to discuss about 12th session of Chemistry and 8th session of Gaseous State, which belongs to first semester BSc, affiliated to Bangalore North University. In this session, I have to discuss about Joule-Thomson effect, Joule-Thomson coefficient, and inversion temperature. The main objectives of these sessions are Joule-Thomson effect. We have to discuss what is mean by Joule-Thomson effect, then what is mean by Joule-Thomson coefficient, then what is the meaning of inversion temperature. That we have to discuss one by one in this session. Now, after completion of this session, you will come to know about the Joule-Thomson effect. What is mean by that and how it is takes place, that will be a known. Then what is the meaning of the Joule-Thomson coefficient and how to write that is the Joule-Thomson coefficient, that will be known. And what is mean by inversion temperature and what is the application of inversion temperature, that way you will be a known after this completion of this session. Then we know already know about the expressions of change in enthalpy, effect of compression and expansion. What happen when compression is takes place, the gases, and expansion will be takes place, adiabatic and isothermal, whatever may be these process you have already know, and how it is changing the enthalpy, that you have already known. Again, you already know about first law of thermodynamics. The energy cannot be created or not destroyed, but it converted into one form into another form, that you have already know. Then what is the meaning of adiabatic process? Adiabatic process, what happened in the adiabatic process, you have already known these terms in PU second year or in that is earlier, that is a previous class or other sessions, you have already learned this. Now coming to that is the Joule-Thomson effect. When a compressed gas is allowed to expand into a region of low pressure or that is a vacuum through a small orifice, a fall in temperature is observed. Now here simple, when a compressed gas means it is high pressure gas is allowed to expand into a low pressure or vacuum through a small orifice or a small that is a aperture tube, a fall in temperature is observed. This effect is called, that is this effect is observed first by James Joule and Williams Thomson, is known as Joule-Thomson effect. It is also called as a JT effect. Now you usually know how it is takes place. The compressed gas is allowed to expand from high pressure to low pressure through a small orifice, small that is a tube or a diameter, a tube having a diameter is very less, then fall in temperature is observed. And best I give that is an example for this day-to-day life. While that is drinking the tea, no, just we have to blow your air blow no to the tea, no, just we are making, we are closing our lips and we are pumping or we are producing that is a air that will be used, that is a cool, and due to that is a cool air will be comes out. Suppose we say that is a that like no, we will get that is a cool value, cool cold air will be comes outside from the body. Suppose we are saying that is a ha, means it that is a, it indicate as a, it produces ha, means it indicate that is a warm air comes out, but we are making that is a, that like no, it indicate as a, it gives that is air, that is a cold air will be comes. Therefore we say that is a compressed gas is allowed to expand from high pressure to low pressure or through a vacuum, through a orifice or small aperture tube, or that is orifice, a fall in temperature is observed, or cooling effect is observed. And this will be a observed by the observed by the James Joule and William Thomson, and this is known as Joule-Thomson effect. It is also called as a JT effect. The cooling is due to the fact that when the gas expands suddenly. Now, cooling effect is due to the fact that when the gas expands suddenly, internal work is done by the gas overcoming the intermolecular forces of attraction at the expense of its energy. Thus, the temperature of the gas falls. Why it is a temperature falls means it is due to the cooling is due to that when gas is expand suddenly, the internal work is done by the gas in overcoming the intermolecular forces of attraction at the expense of its energy. Thus, the temperature of the gas falls. An ideal gas has no forces of intermolecular attraction, and hence no work of the expansion is done, and the Joule-Thomson effect is not observed in ideal gases. Why the Joule-Thomson effect is not observed in ideal gases means there is no intermolecular force of attraction between the ideal gas. Hence, it cannot be happened. That is a cooling effect or the JT effect is not takes place. In case of helium and hydrogen, however, a heating effect is observed. In case of helium and hydrogen, however, a heating effect is observed. Into a thermally insulated tube, a porous plug is placed at the center and the gas is placed at two different pressure P1 and P2 on either side of the porous plug. Let volume V1 of the gas at pressure P1 pass through the porous plug into the other region of pressure P2, that P1 is greater than P2. Let V2 be the volume of the gas entering this region. As the gas passes through the porous plug, it has to do work at the expense of its internal energy. Let the net work done be W is equal to minus P2 V2 minus P1 V1. From the first law of thermodynamics, delta E is equal to Q plus W. As the conditions for the adiabatic process means Q will be a 0, means there is neither heat is liberated nor that is absorbed. Therefore, Q is nothing but constant. The heat will be remains constant. Therefore, delta E is equal to that is a W. It became internal energy is equal to that is a work done. Therefore, we know that is delta E is also can be written as E2 minus E1, and that equal to work done. You have already know that is work, that is W is nothing but from that equation. No, from this equation we can write in this equation W is equal to, we know that minus P2 V2 minus P1 V1, where E1 and E2 are the internal energies of the gas before and after expansion respectively. Or we can write that is here just making that is E2 minus E1 is equal to minus P2 V2 plus P1 V1, correct? Then I can take that is E2 remains as it is. This is minus that side means it became a plus P2 V2 equal to, then I will transfer E1 to right side, therefore minus it became a plus E1, then it already plus is there, that is plus P1 V1. Then again, since we know that H is equal to E plus PV, that is a heat content is equal to internal energy plus the product of temperature and pressure. Temperature, that is pressure and volume. Therefore, we can say that is this also can be written as H2 is equal to H1, means the equal to, that is a delta, the it can be said that is a H2 means change in heat at a 2, that is 2, that is final minus the equal to change in heat in initial. This can be also written as H2 minus H1 equal to 0. Therefore, we can write, this is simply we can write now here. This is how it is written, H is equal to E plus P, we know, like that. No, here suppose this can be written as this equation. This is the E2, H2 means H2, E2 plus P2 V2. For that I can write H2, and this is equal to for E1 plus P1 into V1. For that I can write H1. Therefore H2 is equal to H1, and this is the, because of the substitute the value of this in this equation, we will get that is H2 is equal to H1. Then I take the left side, therefore H2 minus H1 equal to 0, and this can be written as, that is change in delta H2 minus, that is final minus initial, means the change in enthalpy, that is delta H is equal to 0. During the Joule-Thomson expansion, the delta H is 0, that is Joule-Thomson effect expansion occurs at constant enthalpy. Usually, no, therefore Joule-Thomson expansion is occurred at constant enthalpy. And now coming to that is a Joule-Thomson coefficient. It is also called as a JT expansion, that is coefficient. No, therefore Joule-Thomson expansion occurs at constant enthalpy, because I show that is a Joule-Thomson expansion occurs at constant enthalpy, and the fall in temperature depends on the initial temperature and pressure of the gas. Therefore Joule-Thomson introduced a term called that is a Joule-Thomson coefficient, that is represented as mu, which is defined as the rate of change of temperature with pressure, rate of change of temperature with pressure at constant enthalpy, called that is a Joule-Thomson coefficient. What is, how do you define that is Joule-Thomson coefficient? Means the rate of change of temperature with rate of change of pressure at constant enthalpy. dt, that is a dt divided by dp at constant enthalpy, it is equal to, that is a Joule-Thomson coefficient. If here if mu is, that is mu is nothing but Joule-Thomson coefficient is positive, then cooling effect is observed during the expansion. If mu is negative, then heating effect is observed during the expansion. Therefore here inversion will be takes place. If mu is nothing but it is a positive greater than 0 value, then cooling effect is observed during the expansion. If mu r, that is a Joule-Thomson coefficient is negative, then heating effect is observed during expansion. Then when mu is 0, then what happen? When mu is 0, no heating or cooling effect is observed, which is called that is a inversion point. Therefore we say that is a, when mu is equal to 0, then there is no heating or cooling effect is observed, and that temperature is that effect, that point is called that is a inversion point. Therefore what it say, that is a, the process in which the Joule-Thomson coefficient is 0, then no heating or no cooling effect is observed, and that point is called as a inversion point. And this temperature is called that is the inversion temperature. At that point, inversion temperature coefficient is equal to 0. At that point temperature is exist, that temperature is called that is the inversion temperature, that is represented as Ti, that is the inversion temperature. How it is the inversion temperature defined? The inversion temperature is defined as the temperature below which if gas expands adiabatically, into a region of low pressure, region to a low pressure, cooling or fall in temperature is observed. Therefore, we say that is the temperature below which if a gas expands adiabatically into a low pressure, region of low pressure, fall in temperature is observed. If a gas is undergoing adiabatic expansion above this temperature, the heating effect is or rise in temperature is observed, and this temperature is called that is the inversion temperature. Therefore, we say that when the below that temperature, that is a cooling effect is takes place, and above that temperature, above that point, above that temperature, the heating effect is observed. uh, that temperature is called that is a inversion temperature. Now therefore, helium, that is hydrogen and helium, have very low inversion temperature, that is around 193 Kelvin and 33 Kelvin respectively. Hydrogen having a 193 Kelvin inversion temperature, whereas helium having a 33 Kelvin temperature, that is inversion temperature. Okay, and they show heating effect when subjected to the JT effect. This will be a shows that is a Joule Thomson effect at room temperature. Most of the gases are already below their inversion temperature at room temperature and generally show a cooling when subjected to the Joule Thomson effect. The inversion temperature is related to van der Waal equation constant, that is the Ti is equal to Ta by 2A divided by Rb. Here Ti can be calculated knowing the van der Waal constant, that is from the gas A and B and R value suppose we are knowing, then Ti should be a calculated, that is called as a inversion temperature, and Ti is equal to 2A divided by Rb is called that is a inversion temperature, and this equation is called as a inversion temperature equation. So far we have discussed in this session Joule-Thomson effect, Joule-Thomson coefficient, inversion temperature. We have already learnt or we have discussed in this session. So you have already understood everything. Then I will ask some questions. You have to answer them. First question goes to inversion temperature of hydrogen gas is A option 200 Kelvin, B 193 Kelvin, C 33 Kelvin, D none of these. Choose the correct option for this question. I will give just 10 seconds for you people. The B option is the right option for this question, because the hydrogen gas having a inversion temperature 193 and 33 having a helium, no, therefore 193 Kelvin is the right answer for this question. Then second question, inversion temperature of helium gas is A option 200 Kelvin, B option 193 Kelvin, C option 33 Kelvin, D option none of these. Just I will give 10 seconds for you people. You have to choose the correct answer. The C option is the right option for this question, because inversion temperature of helium has the 33 Kelvin, whereas 193 having a, that is a hydrogen. Okay, therefore C option is the right answer for this question. Then third question goes to when temperature coefficient is 0, no heating and no cooling effect is takes place, called inversion point, B melting point, C critical point, D none of these. Just I will give 10 seconds for you people. You have to choose the correct option. The A option is the right option for this question, because the when temperature coefficient is 0, that is the mu is equal to 0, no heating and cooling effect is takes place, and that point is called that is the inversion point. If the temperature will be there, that is called as a inversion temperature. If pressure will be there, that is called as a inversion pressure, inversion volume, whatever may be. But that point no, therefore that point is called as a inversion point. Therefore, E option is the right option for this question. Then fourth one, the inversion temperature is equal to A option 2B divided by RA, B option A divided by 2RB, C option 2A divided by RB, and D option none of these. I will give just 2 seconds for you people. You have to choose the correct answer. The C option is the right option for this question, because the inversion temperature is equal to, this is the Ti is equal to 2A divided by RB, and this is the equation. This is called as a expression for inversion temperature, that is Ti is equal to 2A divided by RB. Hence the C option is the right answer for this question. Then fifth question goes to Joule-Thomson coefficient is equal to A option, that is delta H T divided by delta P at constant enthalpy, delta H divided by delta P at constant temperature, delta H divided by delta T at constant pressure. None of this. Just I will give 10 seconds for you people. You have to choose correct answer. The A option is the right answer for this question, because Joule-Thomson effect, or that is a Joule-Thomson coefficient, that is a mu is equal to rate of change of temperature to the rate of change of pressure at keeping that is a enthalpy as a constant. Therefore, delta, that is a delta T divided by delta P at a constant enthalpy is called that is a Joule-Thomson coefficient. And this completes that is a this session. And for preparation of this session, I have made the reference books. By using these reference books, I have prepared this session. Thank you.